few people have had questions about naming compounds. So here's what I suggest that you do. I suggest you go to page 105 in your textbook. There's this inorganic nomenclature flowchart, and you need to follow the flowchart when you're solving these problems. So I'm going to do a few examples, but the rules for naming are just that. They're just rules. They're never changing. And so you just have to really memorize them. So let's look at this first example. So in this first example, we have something that has calcium and something that has chlorine in it. So first we need to figure out whether or not this compound is ionic, molecular, or it's an acid. So calcium is a metal. I'm going to write an M underneath it. Chlorine is a nonmetal. So anytime you have a metal and a nonmetal together, the type of compound it forms is an ionic compound. So the next thing you need to do is you need to look at the metal, which is calcium, and you need to decide whether or not this ion forms more than one type of ion. Well, everything that's in group 1A or 2A or 3A and silver, they do not form more than one type of ion. Calcium is in 2A, so there's not more than one type of ion formed. So to name this then, you would write the name of the cation. The cation is calcium, so you'd write calcium. And then you're going to write the name of the anion, and you're going to change the ending of this anion to IDE. So the suffix is going to be IDE, so calcium chloride. Let's look at another one. Okay, so this next one we have something that has a carbon in it and something that has bromine in it. Carbon is a nonmetal. Bromine is a nonmetal. Therefore, this type of compound is going to be a molecular compound. So for molecular compounds, we write the prefix, which we would find as a subscript written next to the element, and then we write the name of the first element. Since this does not have a prefix, since this does not have a subscript, there's only one carbon, we just write carbon. There's no need for a prefix. So we write carbon. Now we look at the next element. We write the prefix 4 is here. So the prefix for 4 is tetra. And then we change the ending to IDE, so tetrabromide. So we have carbon tetrabromide. All right, let's look at another example. So this time we have the name of the written name, and we want to go to the formula. So we have calcium oxide. So first we need to determine whether or not this is ionic, molecular, or an acid. So here we have calcium. Calcium is a metal. And then oxide. Oxide is for oxygen. Oxygen is a nonmetal. So we have a metal and a nonmetal. So this is an ionic type of compound. So we're going to write the name of the metal, or write the symbol for the metal, calcium. We're going to look at the charge on this ion. Calcium is in 2A, so it's going to have a 2+ charge. Then we're also going to examine oxide, oxygen. So the oxygen anion, right, is 2-. So we're going to think about how these are going to combine with each other to balance the charge out to be neutral. So since calcium has a 2+ charge, oxygen has a 2- charge, they're going to be able to combine in a 1-to-1 ratio. So for 1 calcium, we'll have 1 oxygen. So we write calcium oxide, CaO. All right, so let's look at this next one. This next one is sodium sulfate. So if we have sodium and then sulfate, sodium is a metal. Sulfate is a polyatomic ion that is composed of non-metals. All right, so we're going to look at the charge on sodium. We're going to write sodium, the symbol, Na. Sodium is in group 1A, so it's going to have a +1 charge as an ion. Sulfate, which you've memorized because I asked you to remember all of the polyatomic ions, is SO4. SO4, sulfate, has a 2- charge on it. So now we have to think about how many sodiums we're going to need in order for this to be a neutral compound. If sodium has a +1 charge and sulfate has a 2- charge, we'll need 2 sodiums for every 1 sulfate. So we write Na2SO4. Okay, so let's look at this example. So for this example, we look at K. K is potassium. Potassium is a metal, and we're going to look at SO4, sulfate. We just saw that sulfate is a polyatomic ion that's made up of non-metals. So in order to name this, we're going to write potassium and then write sulfate. Okay, so let's look at this example. So acids have a hydrogen in them and then 1 or more nonmetals. So we have a hydrogen and chlorine, which is a nonmetal. So this is a binary acid. It just has 2 elements in it. A lot of times you'll see binary acids with the subscript AQ. This subscript AQ just means aqueous, so like in water. And we're going to write hydro plus the base name of the non-metal plus the ending IC, hydrochloric, and then we write the word acid. So HCl is hydrochloric acid. All right, so let's look at another one. This one, we have copper 1 chloride. So anytime you see the Roman numerals tell you that you're dealing with a metal that forms more than 1 type of ion. So you have a metal here and a non-metal, so this is an ionic compound. Copper, Cu, you write that. Copper 1 has a +1 charge in it. Chloride, Cl, has a -1 charge in it. So these are going to be able to combine in a 1-to-1 ratio to form an overall neutral compound. So when you write this, you'll write CuCl. Okay, let's look at another one. So you have Ba. Ba is barium. OH is hydroxide. It's a polyatomic ion. So you have a metal and a non-metal. So you're going to write, and barium is in group 2A, so it only forms 1 kind of ion. So you're going to write barium. And then since you've memorized all of the polyatomic ions that are on page 99, you know that OH is hydroxide, so you just write the word hydroxide.